Hello, everyone. Welcome to another live session at the Reactors. My name is Rav, and I'm the program manager here at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, ask a lot of good questions, and be considerate to others as well when you're asking questions. The chat will be open throughout, and we do encourage you all to participate. Today, we have an exciting session lined up. It's all about powering data engineering and data science, and it is going to be led by two absolutely amazing gold ambassadors, Usman and Neha. And with that, I'm now actually going to add them onto the stream, and they will take over. Hi, Usman. Hi, Neha.
Hi, Rav. Thank you for having us. And
I'm going to
yeah,
share your screen now.
sure. All right, everyone.
And
Thank you, everyone, for joining in. So this session is going to be about Azure DataWorks, and we're going to be talking about everything related to data engineering and data sciences, and how Azure can help you um, use the leverage the services in the Azure for all of its data science and data engineering use cases. So, as you've already heard, I'm Usman Khan. I'm a Gold Microsoft Consultant Ambassador. I've been working in the data engineering domain for the past, you can say, 3 to 4 years now. I've built a couple of open source solutions. I've spoken at a lot of different sessions, and overall, I love to talk about like innovative things. And other than that, I like to play chess and go on adventures. So that's about me. And then we have Neha. Neha, would you go ahead and introduce yourself?
Hello everyone, I'm Neha Hafiz, Gold Microsoft Plus Student Ambassador, and currently I'm leading a chapter at Pakistan named Women Tech Hub, Microsoft Plus Student Ambassador. Also, I am into the data science field and I'm learning a lot about it. I'm kind of a beginner at the level, but still I am so passionate about it. And let's move on the session and see what we're going to share today.
Perfect, perfect. And Neha has been working on the data science team, data science domain for a while now as well. She's really proficient in it. You'll see that in the upcoming slides. So let's first, before we move on to data engineering itself, we should know where do we actually stand in the domain of data itself. So Neha, would you go ahead and tell us a bit about your experiences or your insights on the landscape of data itself? Neha? I think Neha has some issues. No worries. So actually, we started off with data back in 1962. Like data isn't something very new. We have been generating data for decades now. I think it was even before 1962 where when we were generating data, and then like all of different questions and different things got raised, like what do we actually do with the data, because there were a lot of things that could have been extracted from data itself. So there was a lot of you can say potential in the things that were being done. So different researchers, different people, different organization, and different people started experimenting on what they can actually do with the data itself. So this was the entire journey. As we move progress through the years, the big data term was introduced and the data science, and people started working extensively on the data. And that's how basically everything went. And then it was, you can say, Um, y- it was like a snowball effect. Everything fell into place, and different ways, different services were introduced where you could utilize the best possible ways in which you could utilize the data itself. So that's the history of the data. Then we have data engineering and data sciences. You might have heard a lot about data sciences itself, but you might not have heard about data engineering. And the reason being that is that a lot of emphasis is on the data science itself, but not a lot of emphasis is in the data engineering, because data engineering is the actual thing that a data scientist needs, because without a good data, a data scientist cannot bring value to the organization. So data engineering involves designing, building, and maintaining the infrastructure that supports the data processing and storage. Neha, would you tell us a bit about data science? Like, how does data science help in the way different organizations utilize the data?
Yeah, for sure, Usman. Can you hear me?
Yeah, I can hear you.
Okay, so there is a little problem at my end, so I'm not gonna turn on my camera. So, what is data science? There are a lot of questions which just pops up in our mind. It's like, is it about making complicated models, or is it about making complicated visualizations or writing complicated code? I must say, no, it's not about making complicated models or code. It's about how we are creating an impact, or now, if we talk about the impact, how impact can be formed for multiple insights, data products, data recommendations. Now, to do those things, when you need tools now, like to do those things, we need tools for making models and visualizations and writing code. So essentially, our job is to find a real company problem, and what fools us is like we mostly focus on the tools, but we are not focusing on the actual problem which we need to solve. So all is the data science involves statistics and complicated mathematical model just to extract the insights to solve a specific problem.
Perfect, perfect. That totally aligns with what the actual organizations are doing. And we're going to discuss, Neha is going to tell us a lot more about data sciences. I'll just stick to data engineering, although even I know about data sciences as well, since these are both interrelated domains. You're going to see how it's actually related further down the session. So one thing that you might come across is, why are we even talking about data sciences and data engineering in this session and overall in the industry as well? So we should first know about the importance of it. So why should you even care about data science or data engineering, and how can it help you? Essentially, if you're part of any business, you're running any organization, you have data, you are generating data every second. Even if you're a user as well, you have data. So in order to make the best use out of it, you need to mine the data for the things that you actually need to do. And one of the ways you can say utilize the data itself is in improved decision making. Like, you can actually take very good decisions based on the data that you have and the models that you build and the insights that you bring on it. And then you have enhanced customer experience, because if you know what your customer is orienting towards, what your customer is wanting, what your customers needs are, you can like do a lot better job at a personalized experience for your users. So you can make a customer driven or a user driven business or an experience. And then driving innovation, if you want to do something innovative, want to do something different from what other people and organizations are doing, you need to have a place for innovation, and you cannot do that without the help of data sciences or data engineering. And then we have operational efficiency, because you need to minimize the manual input as much as possible. So you need to automate a lot of things, including the data, its pipelines, and its modeling, and everything related to that. So that's how you can that's why it's really important that you focus on your data infrastructure, so you can take good decision, you can enhance user experience, you can drive innovations, and ensure that you have a good operational efficiency. Then you might be wondering, okay, we're talking a lot about data science and data engineering at high level, but actually do we mean by data engineering and data science? If you look at this diagram, you can see what the actual underlying hierarchy of different domains are. Like if you're a data infrastructure engineer, you're responsible for instrumentation, logging, sensor, and data collection point, where you're actually collecting the data. Then you need to, basically, this is the entire stack of the data analytics. This involves all of the roles mentioned in this. Then you have data engineer who is responsible for data flows, infrastructure, pipelines, ETL, and all of those things, so that a data scientist doesn't have to worry about all of the different things that are really tiresome. Let's suppose you have 10 different databases, you need to combine the data into one database. So that's a bit of a problem. That's where data engineer comes in and saves the day for data scientist. And Neha, would you mind telling us about the data scientist and data analyst role, and as well as the machine learning engineer role in this hierarchy and their importance?
Yeah, for sure, Usman. Actually, before I proceed, I really want to discuss one thing, which is, do you know that there is a lot of misconception related to the data science on a lot of platforms, a lot of educational platforms, such as YouTube or etc. etc. So there is, I think there is a misalignment in, or we are kind of confused between what's popular to talk about and what is actually needed in the industry. So, Usman, I would like you to discuss this point. Like, what is actually, what is the biggest misconception in learning the hierarchy, or in learning what actually is happening in the industry?
Definitely, definitely. Actually, the main problem with a lot of tutorials on the internet and a lot of guidance that freshers get is they usually focus on the technical things that are mentioned. Okay, I get it. If you're coming from a computer science background, you're doing a lot of coding, you're building a lot of front end, back end. Like CRUD applications, but unfortunately, the data domain doesn't work like that. Uh, a business user does not care about what kind of like technology you're using, how good you're coding, and everything. All he cares about is what value you're bringing through the data and what insights that you're bringing to the business and to the user itself. And it's your responsibility to enable that. If you can do that with the help of a simple linear regression model, you're good to go. If you can do that with a complex neural network, you're good to go. But the decision is at your hand. All you need to do is focus on the user. You need to be user centric, and you don't need to dive into that much technical details. You just need to understand the problem. You need to understand what problem the user is actually facing, and how do you actually solve it. It's regardless of what technology you use, stack you use. So you need to become a better user, and you need to become a better um, problem solver. That's how you actually fulfill the needs, right?
So basically, we
Moving.
are kind of shifted to a data-driven approach rather than a knowledge-driven approach, right?
Definitely, definitely. So you don't need to focus on the tools themselves, just focus on the data or the problems and focus on how you can actually resolve those using the technology. Don't be tool centric or language centric.
Okay, so now I would like to come towards the hierarchy of needs for the data scientists. So basically, after all the infrastructure and pipelines are being structured properly by the data engineer, what a data scientist or a data analyst do, he or she analyzes the matrices, segments, he do the data featuring, he train the data, he trace the data, and then he deploy it accordingly according to the needs of the problems or of the organization and stuff. So basically, the hierarchy is kind of dependent on the size of organization. For instance, Usman is working in a big organization, so it the whole structure would be totally differently defined according to the size of organization. If I talk about the organization in which I worked in, so basically what happened, I was working with a startup, and the hierarchy was a little different. So the work of the data engineer and the data infrastructure was handled by the one person, and the data scientist and the ML engineer part was handled by the other person. On the other hand, Osman, would you like to explain the structure of your organization?
Yeah, definitely. Actually, the process how it works is um, the end-to-end workflow is something like this. You have a production database or production data source that is actually generating the data, and then what happens is if all of the stakeholders, they need to perform some analysis, they need to take some key decision in whatever they're doing. So the data infrastructure engineer comes in and he actually establishes the infrastructure required for the analysis that they want to do. Then the data engineer comes in, he basically moves the data from one source to the another and transforms the data according to the business needs. And then what the data scientist does is he uses that data and builds models and actually tries to extract the insights out of that data. And then the machine learning engineer comes in and he actually builds models and models to satisfy the business needs. And at the end, we have a business user who is utilizing the data through dashboards and some other things. That's how the actual process works at my organization and the rest of the things that I've usually done. All right. I think that's. I think that clears up the hierarchy of needs. Let's move further. So, all things said, that's the generic data engineering approach. But let's talk a bit about Azure. Like, how does it actually help you, and how does it actually you can utilize it for all of the different services and analytics. So, if you're focusing towards the scalability and flexibility, and by the way, why are we even discussing Azure? The thing is, for the past couple of years, all of the things that are being done, they're usually done on an on-premises data source. Let's suppose you have a server, you're building models on it, you're serving your application on it, and everything like that. And what happens is that if you have any scalability or any peak usage, your server comes crashing down and it has a lot of issues. You can't scale that much. And you have different developers working on it. Maybe it gets choked and all of different issues. So Azure comes in and solves all of those issues with its cloud and serverless features. And so you have scalability and flexibility with Azure. You have integration with other Azure services. Azure has everything, whether you have web, mobile, or AI or data warehousing. Everything is covered with this. So these are different services that Azure has and how you can utilize this. You have pre-built machine learning models. You have ability to process real-time data, and we're going to see like how can we actually utilize these services for our organization and for if you're building something and how can you actually use those. It's not that much difficult. It's pretty straightforward and makes your life a whole lot easier. All right. So if we're talking about data engineering with Azure, what are we actually talking about? We have different services that we can utilize in Azure, which are related to data engineering. We have Azure HT Insights. This is a fully managed cloud service that provides Hadoop, Spark, Hive, and other big data technologies. If you're processing huge amounts of data and you don't want to delve deep into the uh, infrastructure itself, what you can do is just focus on the development of these applications in the languages like Spark or Hive or Hadoop, and just develop your solution. Don't worry about the infrastructure itself. That's covered by HT Insights. And if you're building a data lake on Azure, you can use Azure Data Lake service. This is a scalable and scale data lake that allows organization to store and process large amounts of data. If you have data coming in at huge amount with unstructured, structured, and in any format, you can utilize um, Azure Data Lake to fulfill all of your needs. And then we have Azure Data Factory. This is basically an ETL tool. I talked about moving data from one source to the other. Azure Data Factory is basically an ETL tool which enables moving data from different services to a unified location. It's a really powerful tool. We're going to see like how is it actually working and how can you actually utilize it. And then we have Synapse. Synapse is essentially a data warehouse. If you heard about Teradata, Oracle, and a bunch of other or Postgres itself, or different services from different organizations. This is essentially a data warehouse where you can utilize all of your data, and you can bring out insights from that data, and then you can drive your business analytics from that data warehouse. You can perform all of the analytics from the history handling to the um, campaigns that are specifically focused towards your users. All of that can be done at Synapse and at a fraction of the cost that it would cost you if you were to set up your own infrastructure and everything. That's about data engineering in Azure services. And let's have a demo on Azure, shall we? Let me share my screen and we're gonna see how does it actually work on Azure. Uh, Let me share my screen. Okay, so we're gonna see how do we actually utilize Azure, and okay, perfect. Let's just head over to Azure portal. By the way, this is a portal that you can use to either deploy an enterprise application or a startup or a POC or just your university project. You can do anything with this. All right. So this is the dashboard that we have in Azure. So what do we actually need? We need a couple of things. We need a database. We need a data lake. We need an ETL tool, and then we need to build a pipeline in this. Let's see how can you actually build a database with this. Just head over to SQL databases, then click on create. It's loading. All right. If you click on create database, you can. This is going to give you a couple of options. Like you can select your subscription, you can select your resource group, then you can enter your database name, then server. If you don't have a server, you can click on create new and just select that server location. You should choose this location that is nearest to you, and then you need to choose like what's your workload. And what you need to do is you can see this is gonna cost a lot. This is costing you like on per hour basis, and this is a serverless server. What I would suggest is, since this is a POC, just click on this and click on basic. This is gonna move your cost down to just $6, and you can use this for everything that you want to do. By the way, if you don't have an account, you can just head over for an Azure trial. It's gonna give you $200 for the first month for free, and if you're a student, it's gonna give you $150 for free as well. So you can utilize that on Azure, and then you're gonna select locally redundant storage, and at the end, you're gonna select on networking. Make sure that you have whitelisted your um, IP address so you can access your database. Then we have security. Leave the settings on default and tags and review and create. And then you can click on create. The reason it's not showing create is because I didn't specify a name, but you can do that. That's how you can create a database. I've already done all of these things, just showing these things because this usually takes time, and you can do that on your own as well. It's like essentially the same step. So we have our database done. Now what we need to do is we need to create a data lake. How do we actually create a data lake? We have a storage account here. Just click on create new. Then select your subscription, resource group, account name, region, and then we have performance. Select on standard unless you want a very fast data lake, which we usually don't need, and just click on locally redundant storage. This is gonna be the cheapest option of the bunch. Then click on advanced and make sure that you click on enable hierarchical namespaces, because Azure Data Lake has two versions. It's Gen 1 and Gen 2. Gen 1 is based essentially a blob storage, and Gen 2 is the ADLS, Azure Data Lake, and it has all of the features that a data lake needs, and leave the rest of the location options as it is. All right, I didn't check this. All right, and then network access, enable public access. This is fine. Data protection, if you wanna add some retention policies, you can do that. And encryption, then review, and this is gonna create your um, data lake. So we have our database done. We have our data lake done. Now we need a data factory to do all of the transformations that we need. Just click on new, like create, and just mention the name of the instance, and then select the version, which is v2, and that's it. If you want to add git, you can add git. I would suggest configuring git later because it might take some time. The networking, I would suggest initially using a public endpoint, but if you're in a private network, then you can use a private endpoint. Then we have this. All right, and that's pretty much it for the data factory. So all of these three things are done. Let's see what do we actually have. Let me open my existing resource group. Where is it? Let's open up this one. Where is it? All right, so we have this database. You know what, let me just, all right, perfect. This is the database that we have, and you can query the data using, where do we actually have that? All right, this is the server side, and this is the database that we have in that server. If you just click on OK, this is gonna log you in, or if I continue as this. All right, this is not letting me log in. You know what? Let's just head over to this. By the way, if you forget the password, you can just reset it from here because it's going to be straightforward. Let me name it something useful. Um, Perfect. It's going to be straightforward. You can see my password because I'm going to change it after the session. Perfect. Now let me reset the password, and that's how you can reset the password, because I've been through that situations where you actually forget your password, and I can actually relate with you on that part. All right, let's just log into here. What was the password? No, I forgot the username. No worries, it's gonna be a piece of cake. Yeah, it's FTP. Then let's head over to the database. And we are in. So let's see what do we actually have in here. Um, we have, what do we have? Let's just create table, um, demo, and I'm gonna name it ID and name departure, and then we have ages int. This is not a recommended way of doing this. You need to follow the proper, you can say, format, but I'm doing it for the demo purposes. Let's enter some data into this, into demo of John, and then we have 20. Suppose we have this data. Sorry, it's values. Yep, and here we. Hmm. What's the issue? Right. 50. Right, and basically it was an issue of the length that it had. All right, let's insert some more values. Essentially what we're gonna do is we're gonna um, load the data from this database to a data lake, and we're gonna see what the process is for this. We don't want all of those Johns by the but also generate early, and we can mark as 19. Okay, so we have this. See, and we have this. If we see the data, we have this from. By the way, if you're learning data engineering, I would suggest focusing on your SQL. You're gonna use it a lot more than Python itself. All right, so we have this data here. So let's head over to the data lake. What do we actually have in the data lake? Where is it? So this is the data lake that we have. Let's head over to containers. By the way, this container is actually your, you can say, data lake itself. Where you can need to add a new container. This is illogical. You can say drive where actual data is stored in that. All right, so we have this thing called container called factory, data factory, and I'm gonna load the data to here. You know what? Let me create a separate container for this, and I'm gonna call it reactor. Right, reactor, and all right. So we have this container here. It's empty at the moment, and let's just head over to Data Factory. Data Factory is fun. Like it's more of a GUI thing. You're gonna love this, and it's pretty straightforward. Even if you want to do complex things, it's not that difficult. It really has a good UI, and it has one of the best UIs I've seen in all of the ETL tools. Let's just wait for it to load. Still not loading. Almost done. And there we go. So this is the UI of Azure Data Factory. If you're a data engineer in Azure, you will be spending most of the time here. And Azure Synapse has a similar UI as well. I'll just click on this author tab, and you know what? Before that, I'll need to go to manage, and then I need to create a link service to the server that we had. Let's go over to the SQL Azure database for Azure SQL database. Essentially, we need to build connections to our data lake and to our database. That's what we actually want to do. So this is our database. Uh, it filled all of these things correctly. I'm gonna select the subscription, then the server name. What was the server name? Data engineering server. Yep, I think it was data engineering server. Yep, data engineering server one. Then the database name, it's gonna be the database. Then we have devdb, and then let's connect. Click on test connection. Yep, the connection was successful. Then I'll click on create. This is done. I've already created a connection for the data lake, so we don't have to spend the time there. Now what I'm gonna do is I'm gonna click on new pipeline, and then I need a copy data activity from here. So what this is gonna do is this is gonna um, move the data from one data set to the other, one location to the other. So you can see like I don't have any data set. So this is how it goes. We have a connection, then we have a data set, then we have the pipeline itself. We build the link service, then we have to build the data set. It's pretty easy. Just click on new and SQL, and just click on the link service that you want to use. This is the link service. Then table name. Why did it fail? Hmm. Oh, okay. Actually, the user that we used, it caused an issue. Where is it? Here it is. And it was successful. Let's try it out. And here we go. We created a table called demo. It's showing here. Now let's import this schema and then click on OK. Right, and let's just preview the data that we actually have. You can click on preview. You can see we have the data here: John, Ali, Mark, and all of their ages. And then we need to load the data to where it's going to be our sync. And let's create a new data set here as well. Then click on data lake, and then click on Parquet. Parquet is usually the recommended format. It's really efficient. Don't use CSV. That's a suggestion if you want a peaceful life. Don't use CSV. Then we have Azure Data Lake Storage, and click on this. Okay, this wasn't the right link service, I believe. Data Lake. Okay. All right, you can see the reactor container that we created. Just click on this and click on OK. And file name, we can mention it as demo dot. Let's just mention it as demo. Schema input rate. All right, path does not exist. All right, perfect. Actually, there was no path just like that. That's why. And then we have mapping. Let's import schema. Essentially, you can rename the columns or change the types of this if you want. If you want to remove any columns, you can do that from here. Or if you want to do any SQL thing, you can add here. You can add additional columns from here. And then you have the setting, like how much data you want to use, you want to enable no logging or not, and everything like that. So that's about it. And let's just run it. Click on debug, and this is going to show the output. This is the most crucial part of the entire pipeline, and you just pray that it runs. And it succeeded. Perfect. Let's see the container if we have the data there. Where do we have it? reactor, and voila, you have this data here. If I just click on it or just view the data, it's actually you're not gonna see it because this is in Parquet and this is in Sport Parquet, but the data is there. So that's if this is like a simple example of what a pipeline looks like. If you wanna make complex things from it, you can add multiple uh, data from here. Like these can be different data sources. You can link all of these things together, and you can add like different event driven pipelines as well, like this, this, and this. Like let's suppose if it fails, you can go from here and then from here. Where is it? Here. Like let's suppose if this fails, then do this, if this and this. And that's pretty much it from this. And yeah, that's it from my end regarding the demo. And I hope this gave you insights on how you can actually utilize Azure to build end-to-end pipelines and infrastructure and everything. So moving back to the slides that we had. Neha, do you want to take over and explain the data sciences and what you can actually do with Azure and data science?
Thank you so much, Usman, and that was a wonderful explanation. So, coming towards data science with Azure. So, basically, Azure offers a comprehensive set of tools and services for data science, allowing you to build, deploy, and manage machine learning models and data pipelines. So, here are the key components of Azure data science ecosystem. And here we have machine learning, Azure Machine Learning, Azure Databricks, and Azure Cognitive Services. So, in Azure Machine Learning is a cloud-based service that enables you to build, learn, train, and deploy and manage machine learning models. It provides a range of features such as automated machine learning, hyperparameter, and model deployment capabilities. If we come on Azure Azure Databricks is a Spark-based analytics platforms that provide a collaborative environment for big data and advanced analytics. It integrates with Azure Machine Learning and enables you to process large data set and run distributed machine learning models and workloads. So if we come on towards Azure Cognitive Services, it is a collection of pre-built-in APIs that provide AI-powered capabilities for the natural language processing and computer vision, speech recognition, and so on. Coming towards Azure Machine Learning, this one next slide.
Definitely.
Usman, next slide, I'm saying.
All right.
Thank you. So basically, Azure Machine Learning will help you simply building your ML models by using their automated ML capabilities. Or if you want to build your own model, so you can scale that in the cloud using their Python SDK or any open source framework. And you can manage end-to-end workflows using machine learning pipelines, which is like can say DevOps for machine learning. And it also helps you to deploy your trained models in the cloud and automating business processes or integrating with other Azure services. So, how can we utilize it for data science? It's like in the real world, like we can build and train our machine learning models, create intelligent applications, generate predictions and insights from data, automate business process. We can also get insights and integrating it with other Azure services can help us a lot to gain a lot of insights without doing hard coding. So moving on towards the next slide. So if I talk about Azure Machine Learning end-to-end workflow, it includes preparing data in the cloud using something like Azure Databricks or using Python code in the IDE of your own choice, such as Jupyter Notebook or Visual Studio Code or PyCharm. So after that, you are gonna train and test your model into the Azure workspace, and then you can register and manage the model and deploy it on the cloud service accordingly. Afterwards, Osman, next slide. Now, Azure Machine Learning Service make it really easy to scale out model training in the cloud using powerful GPU and even automatically facilitate provisioning this powerful compute clusters on demand. And you can use the latest GPUs from NVIDIA or to train your model, or you can use the FGPUs to score and train your model super fast. So when you have trained a model, you can deploy it on the cloud using the Docker containers or the edge, so that you can bring your local app to where it can be deployed. So I was trying to join from my browser using my laptop, but it is getting hanged again and again. So, Usman, I think I wouldn't be able to do the demo on Azure.
You're on mute, Usman. You're on mute.
Thanks for that, Rav. So no worries, happens with all of us, and I can show the participants what actual machine learning on Azure looks like and how you can actually utilize it. We're not gonna dive deep into the details since like that's a separate topic itself, but it'll give you an idea of what the actual machine learning space looks like
Yeah.
on
Thank
Azure
you so
itself.
much.
Let me share my screen. So we're back to the portal again. As I said, you're going to be spending much more time here. Let's head over to the Azure Machine Learning space and let's click on this. This was one of the workspaces that I created. If you want to create your own workspace, just click on Create and then uh, mention all of the details: storage account, application insight, container registry. Then we have networking. Then we have advanced settings, then tags. Then it's pretty straightforward. Once you're done creating the machine learning service on Azure, what you can do is just click on the service itself and click on Launch Studio. And this studio is going to be pretty similar to the Azure Data Factory studio that we had, and it has all of those different things that we talked about, and it's okay. So it's much faster than a Data Factory that we had. All right, so this is the dashboard of Machine Learning Studio. You have different options. If you see to the left, you have notebooks. This is going to be a simple notebook that you usually have in Jupyter Notebook. You can just click on this, and these are my own notebooks that I created for some models. Let's see what do we actually have, and the UI is pretty similar to that as well. All the only difference is that you need to have a compute instance on which the actual machine learning or the notebook will run. You need to provision that. How can you provision that? Just head over to compute and click on new, and this is gonna specify, like, this is going to show you all of the available computes and what sort of computer you want, what its prices are. I think the lowest one we have here is for 0.04 dollars per hour, and then we can select the GPU here as well. It can go all up to 14, 15, even I think, yeah, $17. They were much more expensive than these as well. So uh, we have the computes here. You can just specify the compute and it'll assign you a cluster. You don't need to run the cluster all of the time. Like, let's suppose I have already have a cluster. What does it actually have? It has 6 cores and 56 GB RAM. It has 380 disks of GB of space, and it has all of these things. And then what do we actually do? We have, you can create different link services here as well, just like we did in the Azure Data Factory. It's pretty straightforward. Here it is, and it depends upon you what you actually want to do with it. You can select the Spark pools. You can do anything with this. All right, that's the notebooks. Then we have automated ML. Let's suppose you don't want to delve deep into the code itself. You want to do an automated ML job. Just click on new automated ML job, and what this is going to do is this is going to be automate all of your ML task or data science task. You just need to create a data set and then select the data sources. Let's suppose we have this test. Let's name this test. Then we have this data storage. Let's click on data storage. Then we have data lake gen 2. Where is it? Hmm. Oh, okay, it's in the different location. That's why. Where do we? Just showing you the example of like what you can actually do. We have this reactor that we actually created. Then we have this account key. Actually, I don't want to enter the credentials here right now because it's not safe here. Because all of you are viewing this, and this is something that I personally use. So, regardless, this is how you can actually create the different tasks and everything. Then, what you can do is you can configure the job. It's not gonna let me move forward with this, but it's pretty straightforward. Just configure the job, select task and hyperparameters, and then validate and test. That's an automated ML job. Then we have designer, just like we saw in Azure Data Factory, like it was a GUI thing. You can do a similar thing here as well. Let's click on a new pipeline. Where is it? Create a new pipeline, custom. All right, here we have it. If you can see this, like we have this Azure Data Factory, then we have this. You can do all of these things here. Let's. You have different data models, then you have different data as well. If you add the data, you can add your data set here, and you have different models. We have Camembert based. We have GPT-2. We have Distilbert, D5. Every model is almost here, and then if you want different things you can add them from here as well. So but a better suggestion for doing that is using pre-built functions or pre-built pipelines. We have this regression pipeline. I'm going to use this. So this is the pipeline. This is getting all of the data, then it's selecting the columns, it's cleaning the missing data, then splitting the data, then it's training the model. Then we have these two different models, and then at the end it's evaluating models, like whichever is performing the best. And if you need something else you can just drag and drop from here as well. So that's pretty much it about the Azure machine learning space. It's pretty straightforward. I would highly recommend that you guys explore this. It's pretty amazing. You'll love it. But I'll place my bets on the Azure Data Factory and Azure Data Engineering. No offense on the data scientists out there, but I like data engineering more, so I'm a bit biased on that side. Just kidding. It's your own choice, whatever you want to do. All right. So that's it about the demo. I believe. Let me stop my screen and perfect. Let's head over to the slides again. Perfect, perfect. So this is where I'll take your questions. If you have any questions, you can let me know, and I'd love to answer those questions here.
Perfect. Thanks, Usman. Thanks very much for this amazing, informative session. So, we have one question from Rizwan. Um, they ask, is data lake important to have when we have SQL database bases?
That's a really good question. So the reason we head over to data lakes is when you have data from different sources and it's constantly changing, like its schema isn't defined. It's a streaming data or a JSON data or something like that. Or if you have some data that you want to store at a really large volume and you're not actually utilizing that data, like it's used for historical purposes, because in data lake you're costed for the storage, you're not costed for the processing power, and it's really really cheap to store the data. If you have a SQL database, it's running 24/7. If you imagine you have 100 TB of data on SQL database, and you're not using that data, you're not querying that data, then it's better to move it to the data lake. When you need the data, just use any query engine to extract the data from there, or perform any analytics using stream analytics or data lake analytics to do that. So these both have different use cases there. I hope this answers your question.
Perfect. Then another question from Rizwan. How can students practice on Azure SQL and Data Factory?
That's a great one as well. So if you want to practice on Azure SQL and Data Factory, what you can do is you can just head over to Azure's website and just register for students. There is a way where you can register for students. Um, all you need to do is provide your email with an .edu.bk domain, and what it's gonna do is it's gonna give you um, like $150 worth of credits for 1 month, I believe. And that's what you can use to do all of your experiments. Just make sure you don't select the maximum options. Just just rewatch this video and use all of the settings that I've used. It's gonna cost you $6, and you can do all of those things in that. And I've also linked the data set on my well, we didn't use a data set here, but if you want a data set to practice on, I have it on my GitHub. It's open source. You can use that. Okay, Anil has a question.
Yes.
Are
Are
there,
there any tools you use to document your data pipelines?
Uh, unfortunately, there isn't any tool that we can use to document our pipeline. But the way we've solved our these problems is either we use an infrastructure as a code approach. What that does is that converts all of the pipelines from GUI to a JSON-based structure, so we can perform CI/CD and all of those continuous integration and DevOps things in our pipelines, and all of the documentation that's involved in the data pipelines, we have to manually do it, and it is a bit hectic, but I hope there is some tool to do that, but there isn't any at the moment. There is to document the code, but there isn't to document the process itself. You have to make a document out of that yourself.
Okay. And then I think we're going to take one last question. Is Azure also used small, medium enterprise IT companies or just for medium and large?
Azure can be used for all different scale companies, whether it's a small or medium enterprise company, whether it's a medium or large enterprise company. The thing is, it's an emerging cloud provider. It doesn't have the biggest market share, but it has the biggest, you can say, growth in all of different cloud providers. So a lot of new companies are orienting towards it because of its feature rich and cost effective, um, you can say, provisioning. And it only depends upon the use case. Most companies, what they do is they start off with a essential basic POC with the minimum possible configuration, and if their POC is successful, they scale it to a much larger version, and that's how they actually use it. So small and medium enterprises use it along with the medium and large enterprises as well. It's not actually bound to the size of the company.
Okay. I think we can take one more question from Robin.
From
From your experience, do you think no Python for an entry level role is essential, or will SQL be sufficient?
All right, Robin. So it totally depends on which entry level role are you focusing on. If it's a data engineering role, you would need a combination of the theoretical knowledge of the data warehouses, data lakes, ETL tools, and all of these things, along with SQL. That's the first preference, like that the entire package. And Python would be an extra, but that's not something that's primary for the job. What I would suggest is just find one specific ETL tool, one specific data warehouse or a data lake, and one specific language that can be SQL or Python, and just perform like learn about it and do a simple POC. You can use this POC as well that I showed in the session, and that's going to be sufficient. But make sure you have a sound understanding of the high level concepts like the data warehouses, data lakes, ETL, and when to use what. That's about it. And
Uh, Perfect. And Robin, can you do you think can you share with me on the private chat your GitHub repo, which I can share with everyone on the chat?
definitely, let me just give me 1 second. I can share that. Done.
Okay, that's perfect. And I'm going to share this in the chat for everyone. Perfect. Well, I'd like to thank you both, Usman and Neha, for taking the time to present this absolutely amazing session. I hope everyone enjoyed watching and learned something. And with that, we're going to close the session today. And hopefully, we'll have Usman and Neha come back and do an absolutely amazing another session for the reactor and the community. But thank you very much and hope you all have a lovely evening or afternoon wherever you are. Thank you.